we can't represent the function wise of example 1.1 by a mathematical expression. We now consider an example in which there is such an expression. The sound emitted by a precisely tuned and idealized 400 particles tuning fork over the infinite time interval reals equal to minus infinity to plus infinity is the function. Pure tone reals tends to reals where time to normalized pressure assigned is for all t belongs to the set of reals pure tone equal to p sin 2 by into 440 t. Here p is the amplitude of the sinusoidal signal pure tone. This real valued constant. Time in milliseconds in x-axis 0, 1, 2, 3, 4, 5, 6, 8, 7, 8. In y-axis minus 1, minus 0.5, 0, 0.5, 1. Portion of the graph of a pure tone with frequency 440 kilohertz. Okay, from 0 to start here, so on. Okay, like this way. 440 in this example is the frequency of the sinusoidal signal shown in figure. In units of cycle per second or hertz. Units hertz. Simply means that the sinusoid completes 440 cycles per second. Alternately, the sinusoid completes one cycle in 1 by 440 seconds or about 2.3 milliseconds. The time to complete one cycle 2.3 milliseconds is called period. For all t, it belongs to the set of t belongs to set of reals sum of tones of t equal to p1 into 2 by into 440 t plus p2 sine of 2 by into 660 t. Time in milliseconds, some color line of two pure tones, one at 440 Hz dashed line and the other 660 Hz black line. Black line. This is 660 Hz. That dashed line. This is the dashed line. 440 Hz. Color line. This is the color line. Okay. Here RMS root mean square value, that is voltage RMS equal to root of 1 by t integral over 0 to t s square into t dt volts. Here the voltages between the two hot wires and the neutral wire phase 1 neutral and phase 2 neutral, and between the two hot wires phase 1 phase 2 in household electrical power in the US. Here in x-axis 0.002, 0.004, 0.006 up to 0.018. Here 0.002 scale. Here minus 400, 300, minus 200, 100, 0, 100, 200, 300 up to 400. Here, this is the neutral point, dot, long thin chain line. So, here, phase 1, this is a phase 1, dot line. This is a phase 2, phase 1 neutral. Here, phase 2 neutral. This is phase 1 phase. Okay. The voltage between two hot wires and the neutral wires. Phase 1 neutral, phase 1 neutral, and phase 2 neutral, phase 2 neutral, and between two hot wires, phase 1 and phase 2, phase 1 and phase 2. In a household electrical power in United States. Images. Image equal to 10 to 0 to 11 into 0 to 8.5 implies 0 to B max. Okay. B max is the maximum grayscale value. 0 is black and B max is unit white. The set 0, 11, 0, 885 into 0, 85 defines space of the sheet of the paper. More generally, a grayscale image is a function. Image equal to vertical space, horizontal space equal to density. Color image intensity is the black and white. Intensity equal to black and white. Color image equal to vertical image into horizontal image equal to density. Here RGB value assigned by color image. Where is the color image? At any point x and y. In its domain is the triple RGB belongs to intensity, the set of intensity given by RGB equal to color image of XY. Computer image equal to discrete vertical space into discrete horizontal space equal to towards integer 8. Grayscale image left. Okay, grayscale image. And it's enlarged pixels, right? This discrete vertical space equal to 1, 2, up to 300. Discrete horizontal space 1, 2, up to 200. Integers 8, 0, 1 up to 85, 280 to 255. Picture element is the pixel. In customary to say that a computer image source 300 cross 200 pixels, whereby pixel is an individual picture element. Color map index, that is in a computer representation of color image that uses a color map. Pixel values are elements of the set color map indexes. The function display converts these indexes to an RGB red, green, blue representation. Color map index display color map indexes intensity specified as a color map table red, green, blue. Image display device monitor. Color computing image equal to discrete vertical space into discrete horizontal space tends to images 8. Color map indexes equal to 0 to 255 together with the display function. Display equal to color map indexes following to intensity. Display assign color map indexes in 3 RGB color intensities. Video signals. A video is a sequence of images displayed at a certain rate frequency. Illustration of the function video. Image set 0 here, 3 by 30 here, frame. It means 1 by 30, 2 by 30, then so on. Frame times equal to 0, 1 by 30, 230, and so on up to n30. Okay. This range is set of images. Image set for analog video. Each images in image set is a function of the form video frame equal to discrete vertical into horizontal equal to intensity. The image is composed of a set of horizontal lines called scan lines. Scan line is the image is composed of set of horizontal lines called scan lines. Okay. Scan lines. Video frames image set. Time t belongs to frame times. Video equal to frame times into discrete vertical space, horizontal space, intensity. RGB equal to video cap txy. Illustration of the function video. 0, 1 by 3, 2 by 3, n by 3, 30. Red, green, blue values. Red, green, blue. Illustration of the function video. RGB, XY, illustration of the function video of t into x of y equal to video caps t x of t comma x comma y. Signal representation physical attributes. The changes over time in the attributes of a physical objective device can be represented as function of time or space. The position of an aeroplane can be expressed position equal to time to follow reals. For all t belongs to time, positions of t equal to position of t equal to x of t, y of t, z of t. Okay. Is its position 3-dimensional space-time t, the position and velocity of the aeroplane function s colon time towards reals. 6. Where s of t equal to x of t, y of t, z of t, vx of t, y of t, vz of t. Gives its position and velocity at t belongs to time. Theta equal to time equal to minus 50 plus 50.